Okay guys, so we're going to revisit long division. Some of you have a love-hate relationship with long division. And if you take it slowly and you remember to do a clue board, you can do long division. But I have good news, you also in grade 6 may choose to not use the normal long division method, but to rather use the method called chunking. So I'm going to start with refreshing your memory on long division, and then I'm going to do the same sum but with chunking, and then you can decide which method works best for you. I have actually found that chunking works better for me, so I usually don't use long division. They're very much the same, except for chunking allows you to use whichever number you want that goes into the number. You don't have to find the amount that it goes in exactly. But anyway, let's get started and see how much you remember. Then I'm going to do 3728 divided by 35. The first thing I want to do when I do long division is maybe just get a bit of a clue board going. But okay, maybe not the first thing. I'll do that as needed. So I can start by saying, does 35 go into 3?
Yes.
No. Does 35 go into 37? Yes. So it goes into 37 once. And then I say 1 times 35 is 35. And then I say, well, what's the difference? 2. Now I bring down my next number. That's it, 2. Process starts over. Does 35 go into 22? No. So I now say it goes in there 0 times. What is 35 times 0? 0. So I'm back at 22. So you could have skipped this step and simply brought down the 8 to that top number 22. But just to remind myself that I must put a 0 there, I actually do this, and now I bring down, because you mustn't forget about this 0 here at the top. Okay, now I'm going to check how many times it goes into 228. Now for me that might mean a clue board. So a clue board for me is doing easy sums with 35. Not stuff like 35 times 7. I don't start with those. I start with the easy ones. Times 10, that's 350. Too big or too small? Too big. Okay. Remember, I'm looking for 228. Huh? I'm looking for 228. And I now need to check how many times it goes in. What I do now is I half. What the half of 10 is? 5. What's half of 350?
175.
Good. 175. Too big or too small? Small. What have I just learned? I'm looking at something. The answer must either be 6, 7 or 8. Now I can look at different ways to get 6, 7 and 8. But you know what I'm going to do? What's 35 times 2? 70. Check this out. What's 35 times 7 then? Now 5 plus 2 is 7. Can you see? So this one plus this one will give me the answer for 35 times 7. If I add them up, it's 145 plus another 100, so it's 245. Do you see how I did that?
Yes.
If I have the answer to 5 times 35. I have the answer to 2 times. This 5 plus this 2 gives me 7. So instead of working out 35 times 7, I just say I have the answer to the 5 times 1. I have the answer to the 2 times 1. 5 plus 2 is 7. So this one plus this one must give me the answer to 35 times 7. Okay. So my clue board only contains sums that I can do out of my head, or easy plus sums. I don't really use difficult things like 30. It's not difficult, obviously, but it takes a little bit of breaking down for me to do this sum. So I try and build these sums in all kinds of creative ways. Now, 245, too big or too small?
Too big.
Too big. I'm pretty sure my answer is going to be 35 times 6. Okay, what was my answer? What's the easiest way to find this answer?
Take your answer times 7 minus 35.
That is a brilliant way to do this. I know that 7 is 1 bigger than 6, right? So I'll need to take 135 out from there. So if I just take this minus 35, that's 210. Okay. And that is then the right size. So 210 is what I'm looking for. And 210 I got when I did the times 6. Now guys, what I've just done is exactly what we'll do in the next method anyway. So it went in 6 times exactly. And that gave me 210. And the difference is then 18. Now tell me, is 18 bigger or smaller than 35? It's smaller than the 35 that I was dividing by. So I'm done. Okay. Is there anything left to bring down? No. That means I'm done with the sum. That is now called your remainder, right? But just as a side note, your answer to this sum is 106, remainder 18. But that I want you to write the remainder 18 as 18 out of what was my divisor? 35. And that is the same as my denominator. So that 35 is what my remainder goes on to. That just means my remainder is less than 1. Okay, it's a fraction. And now you even have it as a nice little fraction. Please note, this is not the same as 106, 18. Okay, so your remainder can't just be turned into a decimal. Later on when we do decimals, I'll explain that better. Same answer. Okay. Now, let's start with chunking. In chunking, what I like about this method is every child's one can look different because you just need to make up nice big chunks of 35 and you need to keep subtracting them from the 3, 7 to 8, from the big number. Okay. So, again, I'm going to start my clue board in the same way, but now I'm going to aim for something that is close to 3, 7 to 8. Okay. So when I start my clue board, to get 3,700, I'm thinking if I times this by 100, I'll get 3,500. Yes? Is that quite close to my original answer?
Yes.
To my big number? Yes. Is it the closest I can get? No, not necessarily. But I don't have to be as close as I can get. I can go as close as I want because I'm just going to keep minusing. So what I do is I have 3, 7, 2, 8. And now I'm minus, and I'm going to try and color code this for you. I use the times 100 equals that. So I'm going to minus 3,500 now. And I need to just keep tabs on the fact that I was timesing by 100 to get that answer. Okay, what's left? 2, 2, 8. How can I get 2 to 8? Now this reminds me again of the other sum, because we just went through that mission. But now I can only use the easy ones if I want. What's 35 times 10 again? 350. Can I minus that? No, it's too big. What's half of that?
5.
So half of this will be? Is this smaller?
Yes.
Is it close to 2 to 8?
Sort of.
It's sort of close. Is it the closest I'm going to get? No, but it doesn't matter. With chunking, you can use whatever chunks you want. So I want to use this because I like times 5. I don't like times 7 and all kinds of tricky stuff. So I'm just going to use, and now I'll use another color. I'm going to use this part now. Okay. I want to do, oops, no. I want to use this part. I'm going to remember that it was times 5 that gave me this 175. And you can use any number you want, but the closer you get, the shorter your method's going to be. If you keep using numbers that are not very close, it's just going to take you a little longer. That's all. Okay. So when I minus now, I get 3. Here I'll need to borrow. 12 minus 7 is 5, right? And then 1 minus 1. I get 53. And now I need to check. 35, well, what's 35 times 2?
70.
So that's already too big, hey? So the only thing that can still go in there is 35 times 1. I'm using the times 1. So I'm minusing 35 now. And that leaves me with 18, I'm assuming, because that was our remainder previously. I'll borrow. That becomes a 4. That becomes 30 minus 8. 30 minus 5 is 8. 4 minus 3 is 1. And that's then my remainder. But now, what's my actual answer? Josie?
We need time the 100. We need a plus.
Mm-hmm.
100.
Yep.
And 1. All the times you use.
Excellent. I need to plus all the ones that I used. I used the 100, I used the 5, and I used the 1. And that gave me 106 with a remainder of 18.
18, 36, 5.
And look back. Okay, so if I ask you to write 78 as a product of its prime factors, I'm asking you to go find prime numbers that 78 can divide by and then use them to multiply them by each other to get 78 as an answer. It all sounds very complicated. It's super fun and easy. You just say, what's my first prime number?
Oh, you did try.
What's my first prime number?
7.
No.
2.
2. What is 78 divided by 2?
48.
It's not possible.
38. No, 39.
Donkey toch, someone. 39. Okay. Now, can 39 divide by 2?
Yes.
Nope, it doesn't end in an even number. So, what's my next prime number I can try? 3. So, what is 39 divided by 3?
3 plus 9 is 13.
13. Is 13 not a prime number?
Yes. No.
Yes, it is. It is. So, I have a prime number there, a prime number there, and a prime number. So, all my leaves of my tree are now prime numbers. So, 78 equals 2 times 3 times 13. You can work that out and see if it gives you 78. It will. And that's all prime numbers. Do you see? So you've split this into prime numbers. Maybe a good thing to do would be to make a list for yourself of all the things you can divide by. In other words, all our prime numbers. What are we going to divide by first? 2. Right? 2 is my smallest prime number. When it can't divide by 2 anymore, you go with 2 all the way until it can't anymore. Then you try 3. You go with 3 until you can't divide by 3 anymore. What do you then try?
4.
No, 4 is not a prime number. So then you try 5. And if it can't divide by 5 again, you try 7. For you guys, mostly by then you'll be done. But after 7, you can try 11. 9 is not a prime number because it can divide by 3, remember? And then 13. And you can always use your prime number list if you need to look further than that. But remember now, these are the numbers that you must divide by. Okay. Let's try another one. I can't decide if I want a big one or a small one. Definitely big. 172. I hope I have enough space. Let's see what this does. Okay, I always start by trying to divide by 2. Will it work?
Yes.
Yes. Do you see why I taught you your rules of division just now again? Because you're asking yourself now, can it divide by 2? You see? It can divide by 2. That'll be 50 plus 35, which is 85 plus 1 is 86. Can that divide by 2?
Yes.
Yep. That's going to be 43. Can that divide by 2? No. So do you see I'm done with 2 now? Now I try 3. What was the rule to check?
4.
Is 4 plus 3 divisible? What's 4 plus 3?
No, 7.
7. That's not going to work. So 3 is out, guys. 3 is not going to work there. 5, is that going to work?
No.
Nope. 7?
Yes. No.
No. 11? No. 13? 49. That'll be 49. No. Let's quickly just check our list of prime numbers. Won't you quickly go to your list of prime numbers? So 43 is there on our list of prime numbers. 43 is already prime. So the moment I start realizing it won't divide by any of my normal prime numbers, I check. And it won't. So the answer to this one is going to be, look at my leaves. That's prime, that's now prime, and that's now prime. So it's 2 times 2 times 43. And that's how you write a number as a product of its prime factors. Or how you do what we just call factor trees.